This video I will be explaining question 2 of homework 10. So first we need to define what is a wide sense stationary process. So we say a real stochastic process x of t is a stationary in the wide sense. Sorry, this is not process, this would be sense. So if the mean of that process is a constant and its autocorrelation only depends on the interval t1 comma t2. Now we define what is independent increment process. We say that a process xt is with independent. We say that x of t is a process with independent increments if probability of x of t1 minus x of t2 less equals to x1 and x of t3 minus x of t4 less equals to x2 equals to probability of x of t1 minus x of t2 less equals to x1 in multiplied by probability of x of t3 minus x of t4 less equals to x of t2 for any non-overlapping intervals t1 comma t2 and t3 comma t4. Now we define what is a Markov process. So we say that a process x of t is a Markov process if the past has no influence on the statistic of the future under the condition that the present is known. That is, suppose we have n points, n time points, tn minus 1, t2 and t1, where t1 is the future, t2 is the present, and t1 is past. So the probability of x of t1 is less equals to x1 given x of t2 and dot 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 to x of tn should be actually equals to probability of x on t1 less equals to x of 1 given x of t2 equals to x of t2. The other points x of t3 to tn doesn't matter because the future does not depend on the past, it only depends on the present. So x of t2 equals to x2 is the present, so it only future can be predicted only depending on the present. So a Markov process is statistically determined if its second order distribution function is known. That is can be derived from this formula because the probability is only dependent on joint distribution of two variables x of t1 and x of t2. So if the second order distribution function is known, then the Markov process is completely determined. So what is the normal process? A normal process x of t is said to be normal if the random variable x of t1, x of t2 to x of tn are jointly normal for any n, for any t1, t2, tn. So this is a special case of the Markov process. That is, a normal process can be said to be a generalization of the Markov process. So the statistics of a normal process is completely determined in terms of its means eta t and autocorrelation r of t1 comma t2. Now we see what is a strict sense stationary process. We say a real stochastic process x of t is stationary in the strict sense if its statistics is not affected by a shift on the time axis. That is, fx of x1 comma x2 comma xn and t1 comma t2 comma tn is equals to f of x1 comma x2 comma xn comma t1 plus epsilon plus t comma t2 plus epsilon dot 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 comma tn plus epsilon for any n, any t1 t2 tn and any epsilon. So the statistics of the process remains same irrespective of the time. So that is why it is called a strict sense stationary process. Now we define what is a white noise. We say for a random variable vt with zero mean is white noise if the autocorrelation of v is equals to q of t1 into impulse function of t1 minus t2. Also, a mean ergodic process defined as a stochastic process xt is called ergodic if this condition is held. That is, limit t tends to infinity 1 upon 2t integration of minus t to plus t x of t dt is equals to expectation of xt in the mean square sense. Also, expectation of t has to be a constant for a mean ergodic process. So yeah, that's it for question 2. Thank you.